Hello everyone. Kodongwane, the Native God here. Right. For this video, we'll be looking at hydraulic presses. Right. We'll be looking at the formulas that we use under hydraulic presses. Right. These formulas will essentially inadvertently give us formulas that we use in hydraulics in general. So, and formulas we'll get to use for hydraulic pumps as well as hydraulic accumulators. Now, the formulas we're going to cover here, essentially, we will use variations of these formulas when looking at hydraulic pumps as well as when looking at hydraulic accumulators, right? But the formulas covered here, right, are just general formulas we get to use under hydraulic presses, right? When having to look at other other units. So I remember for engineering science under hydraulics, we have 3 units. We have hydraulic presses, we have hydraulic pumps, and we have hydraulic accumulators, right? So the formulas here are general formulas which we will get to use for any and all units, right? Or at least the variations thereof, right? So before we get to the formulas, I want us to look at the hydraulic press itself, how the hydraulic press works, the different forces we get on the hydraulic press, and how those forces come about, right? Now, hydraulic press essentially works in conjunction with a lever system, right? A hydraulic press on its own is pretty much useless, right? So this here is the hydraulic press. Right, so this here is the hydraulic press, right? Like I mentioned, the hydraulic press works in conjunction with a lever system, right? So this here is the lever system, right? So we are going to look at how these two systems work in conjunction with each other and how that affects the forces involved in both the lever system and hydraulic press, right? In looking at the forces involved in the hydraulic press, right, we will get to use concepts based on mechanical advantage, right, as well as Pascal's law, right? So let's first look at both of those terms, right? So mechanical advantage essentially is a multiplying factor, right, for either of these systems, so either the hydraulic press or the lever system, right, which is used to multiply the force coming into the system, right, so that we are able to get a force coming out of the system, right? So the product of the force coming into the system and this mechanical advantage, right, gives us an output, right? An output force, which is the one that actually does the work, right? And then if ever you are looking at a mechanism that when it works, or in order for it to work, right, a fluid within that mechanism has to be displaced, right? You either make you or you are, how can I put this? You make use of one of the two principles, right, which are involved in fluids. That is either Bernoulli's equation or Bernoulli's principle or Pascal's law, right? So for hydraulic presses operate under Pascal's law, right? Now, Pascal's law essentially states that the pressure that is exerted by a fluid in a closed container, right, will be equal in all directions, right? Now, there is a mathematical expression of Pascal's law, right? Essentially, if a fluid is being displaced and that fluid is in a closed container, right, then essentially that system makes use of Pascal's law, right? And then when a fluid is in motion and is not in a closed container, you essentially, or that fluid or that system essentially makes use of Bernoulli's principle, right? But for hydraulic presses, right, hydraulic presses are a closed system, hence it makes use of Pascal's law. So we'll only look at Pascal's law, right? So remember Bernoulli's equation, right? We get to use it under hydraulic systems, but for mechanotechnology, right? So these are essentially the two terms that are the most important that a hydraulic press operates under, right? We will look at the mathematical expression of Pascal's law later, right? First, let us look at how a hydraulic press actually works from the perspective of the forces involved, right? Now, what tends to happen is you have a lever system, right? When a force is applied onto the lever system, right? In order for there to be some work done on the plunger, right? There's an effort that is applied, right? Now, as I've mentioned, that both the lever system and hydraulic press operates under this concept, the mechanical advantage, right? So what tends to happen is, in order for there to be any kind of work done here, right, there's this force that's being applied. So this force has been denoted as the effort, right? EFF, right? The effort is then multiplied by the lever system's mechanical advantage, right? You get a force being applied onto the lever system. That force is the effort. That effort, right, is multiplied by what? By the lever system's mechanical advantage, right? And the product of the effort and mechanical advantage gives us the force essentially coming out of the lever system, right? Which is what? Which is the force we've denoted as the force on plunger, right? Let me go over that again, right? You get the force coming into the lever system, right? The force coming into the lever system is the effort, right? The force coming into the system, right, is then multiplied by the lever system's mechanical advantage, and the product of the force coming into the lever system and the mechanical advantage gives us the force that we get out of the lever system, which is the force on the plunger, right? And then the force coming out of the lever system, which is the force on the plunger, then becomes the force coming in to the hydraulic press, right? And then the force coming into the hydraulic press, right, which is the force on the plunger, is then multiplied by the hydraulic press's mechanical advantage, right? The product of the force coming into the hydraulic press and the mechanical advantage gives us the force coming out of the hydraulic press, which here has been denoted as FR, right, which is short for force on the ram, right? So once you get this force coming into the hydraulic press, that force coming into the hydraulic press, which is the force on the plunger, is multiplied by the hydraulic press's mechanical advantage, and the product of these two gives us the force coming out of the hydraulic press, which essentially is this FR, right, which stands for force on the ram, right? And then this force on the ram, right, then lifts whatever object that is sitting on the ram piston, right? Hence here, as far as the force on the ram, right, we can take it as being equal to the weight of the object that is sitting on the ram, right? Now, what does it tell us? It tells us that essentially, if, for instance, you've been asked to calculate the mass of the objects that's sitting on the ram, if you have this force, right, we have established that this force is equal to the weight of the objects that would be sitting on the ram, right? So you would then use this formula to get the mass, right? So remember, weight is equal to what is this, mass times g, right? Now for engineering science, g, the gravitational acceleration, we take as 9.8, and then if you have fr, you will then solve from this equation, you will then solve for the mass, right? Similarly, if you have the mass of the objects that's sitting on the ram, right, and you have to make use of fr, you simply calculate the weight, and that weight will be equal to fr, right? Now, I forgot to mention here, but again, I would assume that you already know this part, right, that essentially you have two pistons here, right? You have this piston and you have this piston. Now this piston, right, both of these are piston, but this one is referred to as the plunger piston, right? Hence the force coming into the hydraulic press, right? We denoted it as FP for force on plunger, right? So this here is the plunger piston, right? It's called the plunger piston because it plunges, right? This piston, the way it works is that it plunges, right, on this side of the, what is this? On this side of the hydraulic press. So it gives pumping action, right? Hence it being called the plunger, right? And then this side you have another piston, but this piston is known as the ram piston, right? So a simple way of differentiating between the two pistons is by looking at the piston's diameters, right? The plunger piston will have a relatively smaller diameter than the ram piston, right? So essentially, that is how the forces work, or that is how you look at the forces on a hydraulic press as well as lever system, right? You have the force coming into the lever system, which is this effort, right? So that effort is multiplied by the lever system's mechanical advantage. Then you get the force coming out of the lever system. Force coming out of the lever system, which is FP, becomes the force coming into the hydraulic press, right? Force coming into the hydraulic press, which is FP, is multiplied by the hydraulic presses mechanical advantage, the product of which will give us the force on the ram, right? So once you have the force on the ram then rises, lifting whatever object that is sitting on the ram, right? Now the force on the ram is equal to the weight of that object, right? Very important information here, right? Now let us look at the different formulas that we use under hydraulic presses, or just under hydraulics in general, for engineering science and for, right? Now we have already established that the hydraulic press works under Pascal's law, right, which states that if you have a fluid, right, in a closed container, the pressure within the fluid will be equal in all directions, right? Now mathematically, that means that the pressure exerted by the ram is equal to the pressure exerted by the plunger piston, right, or vice versa, right? So the pressure that is being exerted by the plunger is equal to the pressure being exerted by the ram, right? Now the pressure being exerted by the plunger, we are going to denote as P sub P, and then the pressure being exerted by the ram, we are going to denote as P sub R, right? Now what does it look like mathematically, right? So we know pressure, right? Pressure is equal to force over area, right? So to get the pressure being exerted by the plunger, right, for force over area, the force will be the force on the plunger, right, divided by the area of the plunger, right? So remember I said the pistons, right, the way we differentiate between the two will be or we use the fact that the plunger piston is relatively smaller in diameter than the ram piston, right? And the area thereof will be essentially circular, right? So this would be the area of the plunger piston, right? And then the area of any piston, right, will be pi over 4d squared, right? So is equal to the pressure being exerted by the ram. Pressure being exerted by the ram, for the force we use Fr divided by the area of the ram, right? Now we can further expand this formula by using this here, right? Now we did say the area of either of the pistons will be the area of a circle, right? So for the area of the plunger piston, we use pi over 4 times dp squared. The dp stands for the diameter of the plunger, right? Similarly on this side, the dr stands for the diameter of the ram, right? Now because we have pi over 4 as a numerator on either side, mathematically those two are going to cancel, and then essentially you are left with this here, right? So Pascal's law essentially mathematically can be expressed as this here, right? So force on plunger divided by the diameter of the plunger squared is equal to the force on the ram divided by the diameter of the ram squared, right? Now, if, say, you've been given both diameters and you've been given one of these and you're looking for one of these, you can simply use Pascal's law to get the one quantity that you are looking for, right? So this is one of the formulas we're going to be using under hydraulic presses, right? And then here's another one, right? Now this is where we look at the volume being displaced by the plunger. So the volume being displaced, the volume of fluid being displaced by the plunger will be equal to the volume that is being received by the ram, right? So mathematically, this is what that looks like, right? So the V with ears, right, is how I denote volume, right, to differentiate between volume and velocity, right? So for volume, I use this funny looking V, or this V with ears, right? So essentially, how we express this mathematically is that Vp is equal to Vr, right? So this is the volume of fluid being displaced by the plunger, and this is the volume of fluid being received by the ram, right? Now volume is equal to cubic meters, right? Now, what is Vp equal to and what is Vr equal to? Vp is equal to the area of the plunger, right, times the stroke length of the plunger times the number of strokes, right? So the number of strokes it takes to displace a certain volume of fluid from the plunger to the what? To the ram, right? And then as far as how we calculate the the volume of fluid being received by the ram, right? You use the area of the ram, multiply that by the height being lifted, right? So by height being lifted, we are referring to the height that the ram piston is lifted, right? So essentially, how these two pistons work is that this one will move a certain number of strokes, and based on the number of strokes that this is moved, this will then move a certain height, right? Right, so like I said, the area I've already explained, like SL stands for stroke length, right? And then N stands for number of strokes, right? The number of strokes are dimensionless, right? And then you have your height lifted, right? So stroke length is in meters, as well as the height being lifted, that will be in meters as well, right? Right, and then comes the work done. Right, so the work done, the general formula for work done, right? The general formula for work done is force times displacement, right? Now, the formula for work done by the plunger and work done by the ram, right? The force will be, for the plunger, it will be Fp, right? And then as far as displacement for the plunger, the displacement of the plunger is equal to the stroke length times number of strokes, right? So essentially meaning that this here stands for the the displacement of the plunger piston, right? And then as far as the work done by the ram, right, as far as F, you'll use Fr, and then the displacement for the ram is the height being lifted, essentially, right? Right, then we get mechanical advantage, right? As explained when I explained how we get the forces on the hydraulic press, or how those forces come about, right? We have the mechanical advantage, right? And the mechanical advantage, you could either have the same mechanical advantage, so meaning you could have the same in terms of magnitude, you could have the same mechanical advantage for the lever system as well as the hydraulic press, right? But it is important to note that that is not always the case, right? Those are essentially two separate systems. They are just used in conjunction with each other. Hence, the lever system is able to have its own mechanical advantage, and the hydraulic press right, is also able to have its own mechanical advantage, right? The most important thing though is that you know how to calculate the mechanical advantage. And how we calculate the mechanical advantage is essentially, in general, will be the same, right? So the general formula being mechanical advantage is equal to the output force divided by the input force, right? So whichever system you are looking at, to get the mechanical advantage will be equal to the output force divided by the input force, right? And then when looking at the lever system specifically, right, as we've established, the force, the output force, or the force that we get out of the lever system, we denote it as FP, right? And the force coming into the lever system, the input force on the lever system, we denote as the effort. So essentially for the lever system, the mechanical advantage is equal to Fp divided by the effort, right? And then for the hydraulic press, right? Remember I said the general formula for mechanical advantage is the same, right? So this will still be the output force divided by the input force, right? But now because we are now looking at a hydraulic press, right, the forces, right, be it the input or output force, will be different on a hydraulic press than it was on a lever system, right? For hydraulic press, the force that we get out of a hydraulic press, the output force, right, is the force on the ram, hence the Fr, and the force coming into the hydraulic press, right, or the input force is this Fp, which is the force on the plunger, right? Now these formulas, right, the formulas that we've just looked at, these formulas we use if the system is 100% efficient, right? When the system is 100% efficient, then we use these formulas we've just gone through exactly as they are, right? Now we are going to look at what happens if the system is not 100% efficient, right? We are going to look at how efficiency influences the formulas we just looked at, right? And the simplest way we can look at that, right, is from the perspective of how we get efficiency, right? Efficiency in general is equal to out over in, right? Like for instance, if you were to look at the efficiency, the formula for efficiency in terms of just input power and output power, right? The efficiency will be equal to power out over power in, right? That essentially just tells us that efficiency in general is equal to mathematically out over in, right? Now this, as I've noted here, this is not a formula, right? What we are trying to establish with this here is that when we cross multiply, right? When you cross multiply, so essentially when you cross multiply here, in is going to multiply the efficiency, right? So this is what you get essentially, right? What we are trying to establish by doing that is to check which between the two quantities, right, between out and in, does the efficiency multiply, right? And then based on this, the efficiency is going to multiply in, right? Now what does that tell us? That is telling us that each of these formulas, right, every quantity that we take is in, right, when the system is not 100% efficient, how the efficiency is going to influence the formulas is we are going to multiply everything, right, every quantity, right, that is essentially the input, we are going to multiply by the efficiency, right? Now let us investigate what I mean by that, right? Remember, this is Pascal's law expressed mathematically, right? Now this here, right, the force on the plunger, right, on the hydraulic press is the force coming into the system, right? So remember what I said, or how I said the efficiency is going to influence the formulas, right? And based on this, how the efficiency is going to influence the formulas is whichever quantity we take as in is going to be multiplied by the efficiency, right? So between FP and FR, right? FP is the force coming into the hydraulic press, right? So because we're looking at a system that is not 100% efficient, right? When having to calculate any of these quantities, right, we are going to multiply FP by the efficiency, right? So your formula, so that is how the efficiency essentially is going to influence this formula, right? Seeing that this is a quantity for in, we are going to multiply that by the efficiency, right? So this is going to be your starting point, and then from here you can then substitute and solve for what you're looking for, right? Similarly, with the volume of fluid being displaced by the plunger and the volume of fluid being received by the ram, right? This here, again, which since this is on the plunger side of the hydraulic press, this we take as in, and because this we take as in, it means between the two quantities we are going to multiply VP by what? By the efficiency, right? And then as we know by now, VP is equal to the area of the plunger times the stroke length times number of strokes, right? And then VR is equal to the area of the plunger times the height the ram is being lifted, right? And then because we've established that how the efficiency influences the formulas is by multiplying the input quantity by the efficiency. So we multiply this side of the formula with the efficiency, and then from here you then substitute and then solve for what you are looking for, right? Now let us look at the formulas for mechanical advantage for either of the system, so be it the lever system or hydraulic press, right? Now in this formula, right, we again look at which of the two quantities or which of these quantities, right, do we take as the input, right? So this, for the lever system, this is the force coming into the lever system, so we multiply that by the efficiency, right? And then on the hydraulic press, right, the force on the plunger is the force coming into the hydraulic press, so you multiply that by the efficiency, right? And that is essentially how we look at hydraulic presses, right? It is essentially how we look at hydraulic presses. I am going to, probably in the next video, right, I'll be looking at a couple of examples, right? So stay tuned for exercises on hydraulic presses, right, and how we actually apply what we've just learned on this video, right? If you like this video, please give it a thumbs up, right? Like, subscribe, share the video with your fellow students, right? I'd really appreciate that, right? Right. Hope you found this helpful. Yeah? Cheers.